you know max heap, you know min heap also. Let me explain one thing. I am explaining max heap. Max heap I am explaining. Max heap tree. So I am starting now. See this max heap tree. So see some major things which are pending. These only. First one. See this one. First one. Right? Insertion. Max heap tree insertion how? Right? I will explain. So some people are asking, sir, what are the three things pending? Right? Max heap tree insertion, max heap tree deletion. And one more, two things. See this one. Max heap tree available, how to insert one more element. That is the one idea. One more. Max heap tree available, how to delete one element. So try to remember, heap is a one data structure. That may be min heap or max heap. Heap is a one data structure. Right? In this data structure, you can insert a element, you can delete a element. And one more question is going to be, how to create a max heap first of all. First insertion I will explain, afterward deletion I will explain, afterwards I will explain how to create the max heap tree first of all. If you have a max heap, you can do insertion, you can do deletion. How to create a max heap, I will explain that also. Totally three things will come. Right? Let me start the insertion first. Please be comfortable from now onwards. So max heap tree, right? Is it first of all almost, see this one, is it first of all almost complete binary tree? Please check. Yes, right? In between no gaps, lastly gaps, it's okay. It is a almost complete binary tree, everyone know, but I have to try the max heap tree. Let me write max heap tree. You can write whatever way you want, right? No objection at all. Let me roughly write the numbers. See this one, 5, 7, it is a 7 or more than 7, 10. It is a 2, it is a 3, it is a 3 or more than 3, 5. Next one, it is a 5, 10, it is a 10 or more than 10, 15. It is a 4, it is a 8, it is a 8 or more than 8, 10. It is a 15, it is a 10, it is a 15 or more than 15, 20. Next one, it is a 6, it is a 7, it is a 7 or more than 7, 10. Next one, it is a 10, it is a 20, it is a 20 or more than 20, 20. Right, equal also okay, right, you know, definition you know, equal also you can keep. Next one, 10, 20, it should be 20 or more than 20, 30. Right, it should be 30 or more than 30, 50. Please check is it max, anywhere small mistake also if I done, please check. Max heap tree root will be maximum comparing with the children's. 2, 3, 5, 7, 5, 10, 15, 4, 8, 10, 6, 7, 10, 10, 20, 20, 10, 20, 30, 15, 10, 20, 20, 30, 50. Right. And one more thing, how many level tree? You know very well, log n level. Because always byte to byte, left half, right half like that. Big O of log n. That is also okay, fine. Next one. Can you help me inside the computer? This is there in the form of tree or array. Let me write that also. It will be useful. Let me write it. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If required, I will add one by one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 17, 18, 19. Right, so this is the array name is A. Right, so if you want, I will write those indexes also. Let me write it, index number. It is the first place. Because of no gaps there, no need to bother. Level by level give numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. See this one. This array, this particular max heap tree contain 19 elements. I took one array which contain 19 slots. Let me store values also. I am storing values. Let me store. First one 50, 20, 30, 15, 10, 10, 20, 5, 10, 4, 8, 6, 7, 10, 20, 2, 3, 5, 7. There is a one array name is called A, which is the max heap array. You know very well. Same inside computer, it is there. It is for you. Both are equal. Can you help me? What is the topic name? In max heap tree, how to do insertion? Right? Can you say max heap tree contain n elements? How many levels? Log n levels. Inside computer, how it look like? Array format. Everything ready. Everything ready. This is for user. This is for computer. Right? So, and one more thing, I will explain first on the user level. Right? Inside computer, how it is going on, you can verify. Right? In examination, depending upon requirement, you can do this also, you can do this also. But one thing, both will be same. User comfortability, I think this is matters. Right? Just to do, try to do like this first. Right? While storing answer, store in the form of array. See, input is given in the form of array. Output also there in the form of array. In between, you have to do this. Input is given. Just convert this one into like this. Do insertion on this. Afterwards, again store back. If anyone want to do directly here, that is also okay. So, I am starting now. Insertion I am doing. Everything is clear. Let me start. Let me start. See the answer. Insertion I am doing. Please be careful. In this max heap tree, I want to insert. Some people are asking, in this max heap tree, you want to insert one element, it's okay, but which element you want to insert? See this one I am inserting. Insert element in this max heap tree, right? Element 80. In this max heap tree, insert element 80. Now see the answer. Some people are asking, sir, if you want to insert element 80, where will you insert? Can you say inside computer, tree or array? Tree or array? Array only. Right? So, if you want to insert element 80, see this one, nowhere gap, nowhere gap. If you want to insert, you have to insert here only, everyone now. Last place you have to insert. Already 19th place elements are there, 20 place you have to insert. Now, see the topic name, inserting element into max heap. You want to insert element 80, where will you insert? Because of inside computer, no tree, nothing, array only. In the array, last place you have to insert. Array contain already 19 elements. In the 20 place, you have to insert. Just go to the A of 20, insert. Yes, I inserted. So, listen everyone now. This is the array, which is nothing but in the tree, this one. See this one, 19, this is. Here you have to insert. 20 place, insert 80. Both will be similar, right? In array, you have to insert here, which is nothing but in the tree, insert here. That is okay? Yes. See this one, I done the insertion. But one thing is true. Before this insertion, it is a max heap. Before this insertion, it is a max heap. After this insertion also, it should be max heap. Otherwise, you are not done the insertion. You spoiled the tree. Please be careful. It is a max heap, right? Before insertion. After insertion also, it should be max heap. Then only you done the insertion, otherwise you spoiled it. Please be careful. Right? So, because of the max heap, some rules and regulation. What is that one? Right? So, in between gaps not there, that is okay. Already previously it is a max heap. Right? Now, after inserting also it should be max heap. If you want to be max heap, first of all it is almost complete binary tree. See this one. You cannot insert this 80 wherever you want. Right? So, gaps cannot be there in between. So, after 19, 20 place only you have to insert. Yes, I inserted. After insertion is over, you have to make sure that it is a max heap also. Some people are asking how. Max heap tree property. What is that one? Root is maximum or equal comparing with the children. So, you should do like this. See this one. After insertion is over, before insertion it is a max heap, after insertion also it should be max heap. You should do like this one. See the thing what you have to do. You have to do like this one. After insertion is over, you have to ask the parent. What you have to ask? See this one. He is asking the parent. After insertion is over, he is asking the parent. What he is asking? Right? Papa, right? Comparing you, right? So, according to the rules and regulation, you should be greater, I should be smaller. Am I okay or not? He will ask his parent. Papa, am I okay or not? What he will ask? Papa, am I okay or not? What is the meaning? Right? So, he is saying that comparing you and me, you should be greater. Right? Is it okay or not? When he say like this one, he will simply say, Papa, he will ask that, Papa, am I okay or not? He will say no beta. Right? Then he will swap. So, what is the answer? 80 is here, 4 here. See this one, after insertion is over, he will ask his parent, am I okay or not? Because if he is the new person, he have to ask, am I okay or not? When he asks like that one, if at all okay, he will say okay. If it is not okay, he will say not okay. Not okay means SPAP. Because of, see this one, because of is the bigger one, that is the reason he came. Again, I think he disturbed this one. Again he will ask, Papa, am I okay or not? Right, is 80, parent is 10, child is 80, it is not okay, he will say no, then SPAP it, 80 is here, 10 here. Again, he will ask his parent, am I okay or not? Right, he will ask his parent, am I okay or not? So what the answer, he will say no, then SPAP it, 80 is here, 20 here. Next one, he will ask his parent, am I okay or not? No, then SPAP it. So what the answer, 80 is here, 50 here. So please be careful. See the interesting answer, after insertion, you have to adjust also. You have to adjust also. Some people are asking, after insertion is over, you have to adjust also. How you are adjusting? After insertion is over, right? Because of you inserted the new person, he will ask his parent, am I okay or not? This is called as, listen, this is called as, please be careful. This particular one is called as max CP5 method. Right? After insertion, you have to adjust. This adjustment algorithm name is called as max CP5 method. Max CP5 method, right? Please be careful, right? What is the meaning of max CP5? You are trying to convert this particular tree into max C. Before insertion, max C. After insertion, also max C. But as of now, not max C. So you have to adjust. That is called as max CP5 method. And one more. Who is asking whom? Right? Child is asking parent, am I okay or not? Because of child is asking, I think child is below person. Child is asking, this is called as, right? So max CP5 bottom person is asking. If the parent asking child, you are okay or not, that is called as max CP5 top person is asking. Parent means top. If top person is asking, max CP5 top. If the bottom child is asking, right, max CP5 bottom. But one thing is true, right? See, if you say max CP5 also, no problem. Indirectly, direct, max CP5 is nothing but you are trying to convert this tree into max C, right? Please be careful. This adjustment algorithm name, what is the name? Max CP5 method. But to get the clear clarity, who is asking? Child asking, means bottom person asking, max CP5 bottom. If the parent asking, max CP5 top, like that. Right? But one thing is true, right? Adjustment is going on. Can you help in insertion algorithm? Can you repeat again? First step, insert at the last place. Yes. After insertion, you have to adjust also. That is called a max CP5 bottom. Child will ask parent, am I okay? If he say yes, then SPAP it. Otherwise, don't SPAP. Continue until no problem. So after SPAPing, he is having problem. Again SPAP, he is having problem. Continue until root element will come. See this one. Let me check. This came like this. So this is the area which you changed it. This is the path. This entire green color. Please check. First insert, some people are asking, sir, how can you insert directly at the last place? Array random access possible. Array contain already 19, right? If you want to insert one more, 19 plus 1, 20 place insert, then afterwards try to adjust. This adjust algorithm name is called as, what is the name? Let me write the name also. Right? Max CP5. See this one. Max CP5. Max CP5 bottom. This algorithm name is called max CP5. Why it is bottom? Bottom one is asking. Bottom parent and child. Who is the bottom? Child. Child is asking. So this is called max CP5 bottom. If parent will ask, max CP5 top. So you don't bother. So max CP5 if you say also, it's okay. And one more. Please listen. After insertion is over, ask parent problem SPAP. Ask parent problem SPAP. If you observe clearly in every level, see this one. One only going on, which is nothing but this entire green color thing. If you see, what is the answer? See, one path only you are going. One path only. What is this path length? Log n. Log n. See this one. Max CP5 time complexity is equal to, see the answer? Every time, child will ask parent, am I okay or not? It means something like comparison. If he say yes, no SPAP. Otherwise, SPAP. Compare SPAP. So what is the answer? Let me write now. So log n comparisons, because height is going to be log n. Next one, log n SPAPs. Total work is 2 log n. Forget about comparisons or SPAP. Total 2 log n, which will goes to big O of log n. After insertion is over, you have to adjust. That is going to be max CP5 bottom algorithm you are applying. So everywhere problem SPAP. Compare SPAP like that. Log n comparison, log n SPAP, totally 2 log n, finally log n. Now some people are asking, see this one, some people are asking, can you help, which element you inserted? 80. 80 is asking the parent, who is the parent? 4. 80 is asking the 4, am I okay or not? If at all 4 will say no, then swap. Otherwise don't swap. Suppose if you are lucky, what is the answer? Assume that it is the 4. It is the 4. You are inserting element 2. Right? So element is 4. This root is 4. You are inserting element 2. After inserting element 2, ask the parent, do you have any problem? No. Best case 1. As soon as you ask the parent said that no problem, constant time. If the parent sees every time parent saying problem, worst case log n, right? What is the average case? See, total path length. This path length total, if you observe log n, what is the average case is this one. After going half, it will stop. Problem swap. After 2 swaps, stop. What is the meaning? Log n by, you may stop in the middle. If you stop at the end, log n. If you stop at this end, constant. If you stop in between, log n by 2, right? Can you help, So log n time, this is which case? Best case or worst case? Worst case. And the average case also, log n by 2 is nothing but log n. Order of 1, best case. When the best case, after insertion is over, ask the parent, am I okay? Right? Yes, then stop. Parent itself saying yes, oh, you go further. Right? Stop. Worst case, everyone having problem. Average case, until middle problem there, log n by 2, which is nothing but log n. So max CP, right? Max CP5 bottom. After insertion, you are applying the adjustment algorithm, name is called as max CP5 bottom, right? So in every level, one you are keep on comparing. So log n levels, so log n comparison, log n swaps. Right? After insertion, if you keep quiet, then what is the answer? It is not a max CP5. It is not a max CP3. After insertion, you have to do max CP5. Then it will become a max CP3. Right? So worst case time may be log n. So from today onwards, if anyone asks you, max CP3 insertion will take how much time? What is the answer? Log n, worst case, average case. Best case is 1. Right? Best case is 1. Now to get the clear clarity, if you want, I will add one more element only for namesake. Let me ask you. See this one, until 20 element is there. See this one, until 20 element is there. Isn't that 21 place? See this one, 21 place, one more element I am inserting. 20 element is there, 21 place, one more element I am inserting. Can you say who is the root now? As of now, root 10. See this? As of now, root is 10. Right? I am inserting one more element. Please listen. I am inserting 5. Right? First go to the 21, random access possible. Parent will ask the child, do you have any problem? Parent is 10, he is 5. He will ask, do you have any problem? He said, no, stop, best case. Right? Best case, right? Like that. Next one. Some people are asking, sir, can you insert one more element? I am inserting. See this one, 22. Listen everyone now. Make sure that everyone listen. I am inserting element 25. See what will happen. Right? After 21, 22, I am inserting one more element. See, let me insert now. Right? I am inserting now. So 25 will ask the parent, do you have any problem? Yes. 25 here, 8 here. Next one, see this one, he will ask his parent, right? See this one, who is this parent? This one, right? He will ask his parent, do you have any problem? Right? I think it is the 20, it is the 25, yes, problem. It is the 20, it is the 25. That is also okay. So 2 times swap I done. One swap here, one more swap here. Now, he will ask his parent, do you have any problem? Stop. Here, stop. See, log n by 2. Maybe half you will stop. Log n by 2, right? Like that. So I inserted element, what is the answer? So first 80 I inserted, afterwards 5, afterwards 8, like that I inserted. Here also I will do. See this one, let me do the same thing in the array. See this one, let me do same thing. First let me complete 80. Can you help, tree whatever you done, right? In the array also same thing, but in the array you have to apply formula. I am applying formula now. Insert the element in the last place, yes I inserted. After inserting, what will you do? You have to ask the parent, can you help, this 80 parent, what is the answer? 20 by 2, 10. 80 parent is 10. What is the meaning? 20 parent is 10, which is nothing but 80 parent is 4. If you want, you can check. 80 parent is 4 previously, right? So this 80 is asking 4, right? Comparing you, am I greater, right? So according to the rules and regulation, parent should be bigger than child. Am I okay or not? 4 will say no. So 80 is here, 4 here. After swapping is over, again, he will ask his children, right? Sorry, his parent. Can you say what is the 10 parent? 10 by 2, 5. Right? So 80 is asking, right, his parent, right? I am 80, you are 10, is there any problem? He will say yes. What is the answer? 10 will be here. 80 will be here. Again, he will ask his parent, what is the 5 by 2? 2 point something, right? So 2. He will ask, right? I am 80, you are 20, any problem? Yes, 80 is here. 20 here. Next one, he will ask his parent, right? I am 80, you are 50, any problem? Yes, 80 is here, 50 here, like that. Some people are asking, so what exactly you done? See this one, what exactly I done is, after inserting at the last place, right? So I have to ask the parent. What is the meaning? Divide by 2, by 2, by 2. You only say, n elements are there, if you always divide by 2, by 2, by 2. What is the answer? Log n. Log n time. Always is one, always by 2, by 2, by 2. The only thing is from the top, from the last you started, always by 2, by 2, by 2 log n. Worst case what can happen is, extreme right to extreme left you will come. Best case, extreme right to there only will stop. Average case, in between maybe you stop. Let's see this one. I think 80 is completed. One more, 5. Let me check the 5. One more element I am inserting. See this? 5. 21. 21 place I inserted. Can you help me now? What is the 21 parent? 21 by 2. 10 point something. Take the 10. So 10 I will go. Can you help me now? 5 is asking this 80. Who is there here? Can you help me now? I think not 80, 10. 10 there. Sorry for that. Here 10 there. See, so 5 is asking 10, am I okay, right? So he simply said that according to rules and regulation, I should be bigger, you should be smaller. Already we are there, no problem. 5 asking 10, right? Can I swap or not? 10 saying no, stop. So this is the best case. Can you help me? After 5, next element came. What is the answer? I think 25 came. Position 22. Let's start. Right? Again 25 I am adding. Can you help me now? 22. Who is the parent? By 2, 11. So this 25 is asking 8. Right, am I okay or not? This 8 will say no. Rules saying that I should be bigger, you should be smaller. So we have to swap. Here 25, here 8. After swapping is over, right? This particular 11, again he will ask his parent. What is 11 by 2? 5 point something, right? 5. So this 25 is asking, this 20, am I okay or not? He will say no. Here 25, here 20. That is also fine. Next one. Right, this 5 will be 5th place, 25. 25 will ask the 5 by 2, 2. Right, this 25 is asking 50. Right, so can I swap or not? 50 is saying no, because I am already bigger, you are smaller, no need to swap, like that. So this one same. In the diagram, everything is clearly visible, who is the parent and all. Right, that may be user comfortability. Array also okay, you do whatever you want. Right, those people who didn't get in the array, nothing. Right, store last. Afterwards you have to ask parent means by 2, by 2, by 2, by 2. When will you stop? Parent saying no problem, stop. Parent saying problem, swap. Because of always you are dividing by 2, by 2, by 2, log in. Right? Now let me ask you one small line. Now we done, see 3 elements we inserted. First I inserted 20. This is for worst case. This is for best case. This is for average case. So I written also on the board. Right? This method name is called as max CP5 bottom. Log in comparison, log in swap. 2 log in. Right, order of log in, worst case, average case, order of 1, best case. Now whatever we completed 3 insertion, whatever result came, let me check here. Let me check. First 80, first level, because of see it is not visible to some people, that is the reason I am writing 80. Second level 50, 30. Can you say third level 15, 25, 10, 20. Next one, fourth level 5, 10, next one is a 10, 20, 6, 7, 10, 20. Can you help me know what is the last level? See last level 2, 3, 5, 7, right? I think this is the position, this is the value 4, right? I think 5, right? 8. Right, these are level by level I written these. Not visible, if anyone thinking that something is not visible, right, please you take care. Next one, same things are visible here also. Let's check here. Can you help me know? First level answer 80. See this one, 80 available. First level answer 80 available. Next one, second level 50, 30. 50, 30. Next 15, 25, 10, 20. See this one, 15, 25, 15, 25. It is the 15, it is the 25. Next one 10, 20. Next 5, 10, 10. Both will be same. 5, 10. This is also 10. Next 5, 10, 10. Next one 26. Right? It is the 20, it is the 6. Next 7, 10, 20. 7, 10, 7, 10, 20. Next 2, 3, 5, 7. Next 4, 5, 8. Same. Right? Please be careful. So what is the discussion we done from the last few minutes? What is the discussion? Max heap tree insertion. How? Insert in the last place. But one thing, last place means you cannot go wherever you want until which place elements are there next slot, because in between gaps not allowed, right? Just go to the first empty slot, right? Just go there, insert. After insertion, ask the parent, am I okay? If you are okay, stop. Otherwise, right, swap like worst case you have to swap from, right, bottom to top. How many levels? Log n. So log n level, compare swap, so totally 2 log n. Best case, compare, immediately stop. Average until in between you do. So best case, average case is best case is 1, average case and worst case is log n. And one more thing, after insertion you have to ask parent. In the array, how to ask parent? By 2. Last place insert, by 2 you do, parent will come, compare both. And one more, what this adjustment algorithm name is called as max heapify method. Next one, max heapify, okay, but who is asking whom, how I know? If child asking, max heapify bottom, parent asking, max heapify top, like that. Who is asking, right, based on that name is given. I am thinking that max heap tree insertion you are comfortable. Same thing with mini heap also. In the mini heap you will try for minimum, max heap tree you will try for root maximum. If you want, you can check. See this one, before insertion, who is the root? 50y. Before insertion, who is the root? 50y. In this tree, 50 bigger. After insertion, 80 bigger. Always max heap tree root contain maximum element. In the available people, maximum. I think before insertion 80, 50 is maximum, it is there. After inserting 80, 50 maximum, it will be there. After inserting elements, see this one, I think after 80, which one I inserted? 5, because the 5 is not maximum, see 80 only there. After 5, 25 inserted, 25 is not maximum, 80 only there, right, like that. I am thinking that you are little bit okay. Let's go for deletion also. Careful, deletion also let me complete. Deletion, right? Please be careful. See the deletion. Let me take one max heap. Deletion, right, it is the tree. So max heap tree, so let me arrange the values, 10, 20, anything is okay, 30, 40, 50, 50, 30, 50, 60, 2, 3, at the 5, 65, maybe 65, next one, 7, 8, at the 10, 3, 4, at the 4 or more than 4, 15, 10 or 15, at the 25, 65, 25, at the 70. So one max heap tree I took. Please be careful, you are really, so I am saying to you, in the total algorithm subject, easiest topic this only. I don't know the reason, every year there is a question from this. Last year also, before also there. Please follow carefully, because I started from very basic point. Basics onwards I started. Insertion is over, so now see the deletion. One max heap tree I took, can help in how many levels? Right, so because of it is almost complete binary tree or complete binary tree. So what is the answer? Log n levels. Almost and complete both will be similar, other than few gaps. Right, log n level tree there, that is also okay. Let me write now. So this will store inside computer in the form of array. Right, let me take array also. Only for namesake, I have to explain at least one time so that you will get to know what is going on. So how many elements are there? 15 plus 4, 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. If required, I will increase or decrease. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Right? So 19 slots. Fine. Until now it's okay. Now see this. Let me store the elements also. Store the elements also. 70, 65, 25, 65, 10, 15, 30, 50, 2, 3, 7, 8, 3, 4, 10, 20, 40, 50. Array name is A. Array name is A, so fine, everything is fine. I have to start deletion. I am doing now. Listen everyone. Listen, I think one interesting point is coming. Please listen. Okay, can you help me one small end now? Max heap tree greatest advantage. I want answer from you. Max heap tree greatest advantage. Try to remember, max heap tree greatest advantage is going to be, it will, right, root contain maximum element. Means constant time maximum will come. Max heap tree greatest advantage is going to be maximum elements will come with the cheaper cost. Max heap tree is also array, but in the array to find out maximum minimum order of n time, but in the max heap tree to find out maximum, right, constant. In the max heap tree to find out maximum constant, I am okay, but in the max heap tree to find out minimum, no use, order of n. See this one, in the normal array to find out maximum minimum, order of n, one scan, but in the max heap to find maximum 1, but to find minimum, no use, means previous algorithm, so n, right, fine, that one you know. Can you help me now? Max heap tree greatest advantage, maximum element at the top, everyone know. Can you help me now? Max heap tree contain root, maximum element. Are you comfortable with this or not? Yes, if you are okay. Now listen carefully. Listen carefully now. In the max heap tree, everyone listen. In the max heap tree, right? In gate examination, what they will do is they will give one max heap tree. In gate exam, they will give one max heap tree, and they will ask you, right? Max heap tree is given. They will ask you, delete this element, delete that element. They don't say. They will give one max heap tree and they will simply say that from the above max heap tree, if you do one deletion, what will be the resultant max heap tree? They don't say which element you have to delete. From the max heap tree, right, if you do one deletion, show the resultant max heap tree. They don't say which one you have to delete. What do they mean? By default in the max heap, root element will delete. Please be careful. By default in the min heap, right, minimum, right, root element will delete. So that is the advantage. Min heap tree advantage is minimum element at the root. Max heap tree advantage is maximum element at the root. Please be careful. Can you help me now? From the max heap, if I say delete, who will delete? Root. Some people are asking, suppose isn't that in the max heap tree delete some element, can't I delete? That is also okay. Normally root will be deleted. Right? So anything is possible, Google possible, anything is possible. The only thing what I want to say, max heap tree delete, normally root will delete. Suppose if you want to delete some other person, that is also okay. Let me delete this first, afterwards we will delete that also. Right? So deletion means root element you have to delete. Carefully observe what I am doing, how deletion is going on. And one more, please be careful while doing this entire story. At one place also, right, it cannot violate the property of max heap tree. What does that mean? It should be almost complete binary tree. Whenever deletion is going on or whenever insertion is going on, first of all it is a almost complete binary tree, afterwards it is a max heap. Please be careful. Now I want to delete, right, while doing this story. Please take care, it should be almost complete binary tree first, afterwards max heap tree also. I am starting. Everything ready? I am starting. See once. See this one, you are okay with the insertion. See the deletion also. Can you help me now? From this max heap tree, from this max heap tree, simply they will say delete. They don't say delete that and this. Simply they will say delete. See how I am doing. Can you help me now? Deleting max heap tree is nothing but deleting root. See this one, deleting root. Can you help me know who is the root? X is equal to, see this one, X is equal to A of 1. Everyone know. This is array only. This one same. Right? Can you help me now? What is the A of 1? 70. 70 will store somewhere. Can you help me now? If I want to delete this one, see this one. Everyone know. Deletion means what? Deletion means no need to take knife and no need to kill. Physical deletion not required. Deletion means simply replacing. Deletion means simply replacing. Supposition that, see this one. Supposing that I am talking with A. Right? I am talking with A. Assume that there is one person A. I am talking with A. Right? So until yesterday I am talking with A, right? Supposition that I want to delete A, no need to go to their house, no need to kill them. Right? Instead of that, what I will do? Until yesterday I am talking with A, I want to delete. What I will do now? I don't talk with A, I will talk with B. Replace. This is called as a deletion. It is the intelligent deletion. No need to go and no need to kill them. If you do that, what is the problem? Right? You are killing someone. What is the next day will happen? They will kill you back. If they don't kill you, assume that they are a nice human beings, assume they don't kill you, at least police people will come, right? They will kill. Right? You please be careful. Right? So you are talking until now with A, until yesterday with A, you want to delete, no need to say delete and no need to do anything. You don't want to talk, don't talk, talk with someone. This is called as deletion. Deletion is nothing but ignoring. A is keep on calling, you are not lifting phone. This is called as a deletion. Right? So some people, A is calling, you don't want to talk. Some bullshit people, what they will do is, A is calling, right? You don't want, they will lift and they will lift and they will say, I don't want to talk to you. What is the requirement of saying it? Right? You don't want to talk, don't talk. Right? You are talking with A until yesterday, you want to delete, simply, right? Ignore. That person is keep on calling, ignore. Right? After some days, after all, that person also human, right? They may not call back. Right? You can call B, something like that. Deletion means ignoring only. No need to delete physically. Right? Fine. Now can you help me one small line? See this one. I want to delete 70. What is the answer? See this one. Safe side, I stored the 70 in one variable. Safe side, I stored 70 in one variable. Please be careful. Right. Now next one. See the next one. Deleting this element is nothing but ignoring only, which is nothing but, right? So already some element there, you will keep some other element. Overwriting is nothing but ignoring. Already there, how can you keep? That is called ignoring. Right? See this one. 70, I want to delete. Right? Which is nothing but this element will be replaced by, what is the answer? Try to remember. You replace anyone, but first of all, it should be a almost complete binary tree. So what is the answer? Deleting a root element is nothing but first to store him in one local variable. Yes. Afterward, replace this one by some other person, right, which cannot damage anything to the almost complete binary tree. What is the meaning? This 50, replace by 50. Delete root means replace this person by last element, Some people are asking what is the advantage with the last element, right? So last element will be there in the last level and right to left. Right to left gap is okay, almost complete binary tree, but you cannot replace in between. Delete root. Before going to delete, first store him because there may be a use. First store, next replace this one by last person. Yes, after replacing, if you observe, it is almost complete binary tree. It may not be maxi, but it is almost complete binary tree. Please be careful. Right? Delete root, replace by the last person. Yes, it is almost complete binary tree. But you want only almost complete binary tree or you want max heap also? You want max heap also. But one thing, right? See, this person is came from somewhere. Can you help me now? This person is came from where? Can you help me now? This person is came from where? He came from anywhere or last level? He came from last level. Some people are asking me, right? If anyone come from in the max heap tree from the last level normally small people will be there. Last level normally small people will be there, but it is a max heap. It is a max heap. Root is expecting maximum element. But from the bottom, you are taking one of the element you are keeping. Because of he came from the last place, which may be smallest element, which may be, because so many, this one, in all the leaf nodes, one leaf node is smaller. You are deleting the root element, replacing by one of the leaf node. That leaf node is mostly small maybe, right? But max heap tree root expecting maximum element, you are replacing by smaller element. You are replacing by smaller element. Maybe I think it is one of the small element, right? So I think most probably what happened is, it has to go down. Some people are asking, why are you replacing root by one of the leaf node? What is the reason? If I don't replace root by the last element, right? It is not a almost complete binary tree. For that I am doing. I know that, right? Last level people are mostly small people. Still I am replacing. Otherwise, it is not going to be almost complete binary tree. Delete root, replace by the last element. Now I got almost complete binary tree. Problem is maximum element place, right? One of the leaf node is there. Mostly he will go down. From now onwards, what should I do? Already I have almost complete binary tree. I want max heap tree. I have to adjust. Can you help me now? If you want to adjust, whom you have to ask? I think he is the one who came newly. Whoever is new person, whoever is came newly, that person you have to ask. This person I am asking, you came from somewhere, right? Maybe there is a problem with you. You please ask, right? You with your children's. I deleted the root, replaced by the last. I know that last people are small people, right? One of the small person I kept at the maximum place, right? Now I am asking this person, right? So actually, right, this place bigger person should be there. You are the leaf node, still I kept because I want almost complete binary tree. So there may be some problem, right? Because of you came from somewhere else where normally small people will be there, but it is expected to be maximum. So what will you do? Because of you came from somewhere, you may be wrong, you only ask your children's. Because children's are correct because previously they are maxi. Now also they are maxi because the parent is having, right? Parent is came from somewhere. Whoever came from somewhere, they have to ask. Now this person is ready to ask because he came from somewhere. He is ready to ask. How he is asking? Let me check. He will ask both the children. See this one? He will ask this one. First he will ask left child, right? What he will ask? According to the rules and regulation, it is a maxi tree. Root will be maximum comparing with the children. He will ask the left child, comparing you and me, right? Am I greater or not? He will say no. Then who is greater? 65. Comparing 50, 65 is bigger, right? So first to compare the left child is bigger. With that left child, compare with the right child, right? I think comparing root and left child bigger. Comparing left child and right child, overall, what is the answer? Left child is bigger. So whoever bigger, he will goes to root. That root will comes to that place, right? Like that. First compare with left, whoever is bigger. With that compare with right. Then overall who is bigger, that place root will go, root place that will go. I think SPAP is done. See this one, you compared these three are compared with the best one, you SPAP. Again, see this one, because of SPAPing is done, there is a disturbance here. Again he will ask their two children. Can you help me? Who is asking here? Child is asking, parent asking, right? This adjustment algorithm name is called as max CP5 method, but one thing, parent asking, previously child asking in the insertion. In the deletion, right? In the deletion, parent will ask. Parent asking children, am I correct or not? Let's see this one. How he will ask? He will ask the left child first, 50, 60, right? I think comparing left child better. Comparing with that person, right child, I think overall left child better. So finally, see this one. Finally, 60 will be here, 50 will be here. After swapping over again, he will ask their two children. Can you help me? 50, 30, who is better? 50. 50, 50, because of both are equal, no need to swap. 50, 30, 50 better, right? With that 50 right child, 50, 50, both are equal. If both are equal, why are you swapping? Not required. Next one, because of no swapping, stop it. Swapping is there means some change there, right? Swapping not there means you can stop. Can you help, you ever see this one? Parent asking both the children. Again parent asking both the children. So what is the answer? See this one, if you observe clearly, worst case what can happen is topmost level to bottom level, right? Every level, see one every level, compare swap. So again same thing, log in. See if you are lucky, so it isn't that if you are little bit lucky, in the middle you can stop, log in by 2. Right? If you are unlucky, topmost place to bottommost place you will come, log in. Best case, after asking both the children, sometimes maybe no problem. Right? So some people are asking, sir, how? See this one, assume that it is a 50, assume that both are equal. When you ask both the children, they are saying that we three are equal, what is the requirement of swap? You can stop also. Best case 1, right? Worst case, log in. Average case, log in by 2. Exact like insertion, what will happen? Child will ask parent. Deletion, parent will ask child. Right? And one more thing, see this one, see carefully this line. Maximum what can happen? You are keep on swapping like this. You are keep on swapping like this. See this one, this part. I round it also, see this, maximum this will happen. In every level, one swap like this. Now can you help me, what is the name of this algorithm? Max CP5, right, top. Can you help me, max CP5 top, what will happen? Parent will ask both the children, what does it mean? 2 comparison. Whichever is better with that swap, one swap, right? Everywhere, what is the answer? 2 comparison. I am writing now, so everywhere 2 comparison. Right? Everywhere 2 comparison, 1 swap, totally 3. Let me write now. So 2 log n comparison, 1 log n swap, totally 3 log n. right? So next one. So what is the answer? Order of log n. Best case, sorry, worst case and average case. Next one, order of 1, best case. Same thing like insertion, right? The only thing here, parent will ask child. Some people are asking, in the insertion only 2 log n, why here 3 log n? Parent will ask both the child, 2 comparison. With that best one, SPAP is only 1. But in the case of the insertion, right, 1 compare, parent, child will ask parent, 1 compare, 1 SPAP. But here, 2 compare, 1 SPAP. So 2 log n, see this one, 2 log n, let me write now. 2 log n comparison. Next one, 1 log n SPAPs. Total 3 log n. Which will goes to log n, worst case and average case, 1 best case. Now, can you repeat the little bit of deletion? Delete root, replace by last element. Some people are asking, why are you replacing like this? If I replace other than the last person, it is not almost complete binary tree. So replace. After replacing, right? So actually root place bigger one should be there, but you kept one of the leaf node which is mostly small. How can you keep? So you have to adjust. How to adjust? Parent will ask both the child, whoever is better with that SPAP. Best case. Both the children are saying that no need, stop. Worst case, right? Every time SPAP until bottom will come, log n. Average, in between you stop. So every level, 2 compare, 1 SPAP, 2 compare, 1 SPAP, totally every level, 3. 2 comparisons, 1 SPAP, 3 log n time, 3 log n, worst case, right? Average case, what is the answer? 3 log n by 2, which may be log n, yeah, right? Best case, 1 only, right? Like that. So whatever I done, see this one, whatever I done in that diagram, I am doing here. Carefully listen, both same. What is the difference? There in the diagram everything you will do with eyes, but here everything with the calculator. How to do calculator? Let's check here. Let's check. Can you help me know whom you will delete by default? Whom you delete by default? First person. First person is how to delete. See this one, how I am deleting. See this one, how I am deleting. If you want to delete, right, root element, this is the way. First store this person. Yes, I stored. 70 I stored. Replace this 75 after storing. Replace this 70 by last person. Who is that? 50. Yes, because of I replaced this one by last person. Can you see this array contain previously how many elements? 19. I replaced the first one by last one, right? I think 50 came there. Then array size will decrement by 1. This element no more. This element no more. I did see this one. I replaced the first one by last one, right? Because of this element went there. Here no one. Here gap. Actually array size is 19. Because of one element you deleted. Now array size 19 only, now also 19 only, but elements are 18. Previously array size 19, elements also 19. Now after one deletion, right, array size 19, but elements are 18 only. What is the meaning? This is gap. Now can you help me now? After replacing first one by last one, will you keep quiet or you have to ask? See, parent place, right? From the leaf node one person is came. He may be small also, right? He may not deserve this place. Right? You have to ask, he will ask both the children, is there any problem or not? Let's check here. He will ask left child. He will ask right child also. Whom he will ask? Left child first. Some people are asking, why he will ask left child first, why not right child? If you want to calculate the left child, 2 into I. Right child plus 1. Without completing left child, without calculating left, you cannot complete right. First compute the left. What is the answer? 2 into I. Right plus 1. That is the reason left child you will compare. Can you help me now? So 50, 65. 50 is asking 65. Who is bigger? 65. That 65 will ask the right child who is bigger? 65. Overall who is better? 65. 65, 50 plus 65 will go. 65 plus 50 will go. Right? Like that SPAP is done. But one thing, with whom you SPAPed, right? That person will ask. See, with whom you SPAPed? With the second one. That person will ask their 2 children. So what is the answer? 2 into 2, 4. Plus 1, 5. So he will ask both the children. Can say 50, 60, 60 better. 60 and 5, 60 better. Finally, 60 will go here, 50 will go here. With whom you SPAP? 60. That person will ask his children. Can you say 4 into 2, 8. Plus 1, 9. So this 50 will ask 30, 50 better. This 50 will ask 50, finally 50 better. No SPAP. Then you can stop. He asked the left child 50, 30 saying that you are better. 50 is asking again 50, right? This person saying that we both are equal, no need to stop there. So if you observe clearly what happened, always multiply by 2. See, start from this side, multiply by 2, multiply by 2, multiply by 2. That is also log n. If you start from this side, in the case of the insertion, divide by 2, by 2, by 2, by 2. That is also log n. So always multiply by 2 log n. Right, order of log n. Worst case is log n, best case is going to be 1, average log n by 2 log n. Now if you want, you can compare both the elements. Can you compare? Can you say what is the root there? 65, here 65. What is the next level? 60, 25, 60, 25. What is the next level? 55, 10, 15, 55, 10, 15. So both will be similar. Can you help deletion time? Which algorithm you are using? MaxCP5 top. Top means what? Parent asking child. Why parent asking? Parent came from leaf nodes. You don't deserve that place. Right? Actually MaxCP3 top place should be maximum person. Right? Unfortunately one of the leaf node I given chance. You don't deserve that place. He also knows that. Right? He is asking. He is asking. Right? I came from somewhere which I cannot, right? I came from somewhere where I don't deserve this place, but anyhow, right? I am trying my level best. He will ask both the children, am I okay? If they both will say, yes, you are perfectly fine, he will stay. If not, mostly he will go down, confirm, mostly. Best case, very rare incident, right? 1 or 2 times best case will come, but one thing is to best case chance is there. Right? Because of he came from leaf node, 99% he will go down. Sometimes he may stay same place. Best case 1, worst case is going to be log n, average also log n. Right? I will give one more example. For deletion. I am thinking you are little bit okay. Let's give one more example. See this one. Make sure that everyone listen. One more deletion. Right? Just at least follow now. If you are okay with the deletion also, almost it is completed. Deletion. See this one. Deletion. Delete. One more example. Deletion time you are applying MaxCP5 top or MaxCP5 bottom? MaxCP5 top. Deletion, just I am giving one more example. Right, so this may be the case. Right, let me take some values. 20, 30, 40, 50, 60, 70, 40, 70, 80. Next one, 5, 10, 20, 20, 30, 40, 80, 40, 100. Some elements I have to arrange, I arrange. Forget about array and all, you know very well. Right? Let's do one deletion here. Only for namesake I am doing, let's do deletion. Very simple. Let me do this. Mostly listen, right? So let's one namesake, let me do one deletion. Delete root. Right, replace by last. Yes, I done. Next. Delete root, replace by last one. Yes, I done that. Next one. Afterwards, I have to adjust. Let me adjust. See this one. Actually, this place bigger one is expected, but unfortunately, one of the leaf node you replace. Mostly, it will go down. Let's check. It will go or not. Right? See this one. 10, 80, 80, 80, 40, 80. So finally, 80 will be here. 10. With whom you swapped, that person only you go. Once again, he will ask their 2 children. 10, right? 10, 40, 40, 40, 70, 70, 70 better. Right? 70 is here, 10 is here. No need to swap 2 times. First complete 10, 40, 40 better. That 40, 70, finally 70 better. With that 70, 10 will swap. Right? Next one, because of swap is there. See this one here. 2 comparison, 1 swap. Again here. 2 comparison, 1 swap. Again same. What is the answer? 10, 50, 50. 50, 60, 60. Overall 60. So 60 is here, 10 here. Right? This also. Right? This also. You see, this is the worst case. Can you help me? What is the name of this method? MaxCP5. MaxCP5. What is happening? Worst case. Right? Everywhere 2 comparison, 1 swap. Totally 3. Everywhere 3 like that log n times. So 3 log n, which will goes to log n. Why 3 log n? 2 comparison, 1 swap. Everywhere 3. Every circle indicate 3 because 2 comparison, 1 swap. Like that log n time 3 log n, which is nothing but log n. Right? Best case, you can stop here itself. Maybe in the next example, I will do that also. This is, I think if you stop in between log n by 2 log n, this is going to be worst case and average case. Fine. Previously, we felt that deletion difficult. Now, really nothing there. Right? Let's see this also. Right? See this also. One more example. Deletion, one more example. See this one, deletion. Deletion, one more example. Carefully observe this. So see the deletion. One more deletion, see once. Make sure that everyone listen, there is nothing there. So I am deleting now. Delete root. Yes. Replace by. Make sure that everyone listen this interesting problem. Delete root. Replace by last person. So 41. Afterwards delete this. Yes, I deleted. Next one. After deletion, see this one. Actually first place bigger element is expected, but unfortunately one of the leaf node you replace. It's okay. Next, you have to adjust. How? Right? This 41 will ask the left one. Right? 90. He will ask the right one, 71. Who is the overall better? 90. So what is the answer? 90 will come here, 41. See this one. So 90 will go here, 41. I think swap is done. See this one, swap is done. Actually this 41 came from the leaf node. 41 came from the leaf, right? So because comparing both the children's, left one is better. So he swapped it. See, after swapping is over, he stopped. Because see, in this area, all are smaller is bigger. Right? So I done the swap. 41 came here, 90 went there, right? 41 came, he got to know that total left subtrees all are smaller than him. Some people are asking how. Try to remember this 41, see this one. This 41 if you observe, in this path maybe is smaller. 41 is smaller in the right hand side. Right hand side if you see 41 may be smaller, right? But in the left side, if you send that person left side, in that maybe is bigger. So I trapped it. So what I want to say indirectly, directly, right? So deletion best case order of 1 is possible. Some people are asking how. Delete root, replace by the leaf node, right? So can you help? Leaf node is went from this side. So in this area, this 41 may be small, but I trapped this person to go this side. Then in this area is bigger. So one swap only I done, constant time. If I don't say this example, people thinking that, right, max heap tree deletion order of 1 no chance, best case possible. I proved it. Delete root, replace by the leaf node. Yes, afterwards he is asking both the children, right? So I trapped him to left side. Actually, if at all he will go right side, he will come until down. Because in the right hand side he may be smaller, something like that. But in the left side he is bigger. So I trapped him to left side, right? Afterwards I blocked him. See this. He want to go further, not possible. Only one swap I done, which will take constant time. Right? Only one swap. So finally I want to say to you, max heap tree deletion will take best case 1, worst case log n, average also log n. This is for best case. This is for worst case. Previous one for worst case and average case. Right? This is for the best case. Please see. One swap only done. Delete 100, replace by 41. After swapping with the left one, block it. So constant. Let's see the one more problem for the deletion. See this. See the one more problem. Ten like this. Isn't that so many, all are 10, some numbers, right? So isn't that these are the things, right? So let's see the deletion. Many people know what is the deletion for this. This one also answer also everyone know. There is one more example for a deletion. Can you say first step? Delete first element. Yes. Replace by last one. Yes. And after replacing, then delete this. Next one, after replacing, this one deleted, replaced by the last one. Now afterwards I have to do max if I top. What is the meaning? Parent will ask both the children. We will ask left child, no problem. He will ask right child, no problem. Stop. Right? This is the best case. See, one swap also not there. Delete root, replaced by the first one. Afterwards ask the children, they both are saying no problem. Stop. So deletion best case 1. This is also one example. All elements are equal, deletion 1 will come. That is okay. All elements are right, all elements are same, then deletion becomes 1. All elements not equal, then also 1. Previous example, try to remember, in the max heap tree deletion and insertion will take best case 1, worst case and average case log n, right? Please be careful, right? Let me write that note, that is the major important one. See this one, note, see the note. In min heap or max heap, in min heap or max heap, right? In min heap, max heap, to delete or insert in min heap or max heap, to delete or insert an element in min heap or max heap, to delete or insert an element will take best case order of 1 time, worst case and average case how much time? Order of log n time, right? Where n is number of elements in the tree, right? See this one, min heap or max heap tree, these are trees. Min heap, max heap tree, these are the trees, please be careful, right? In min heap tree or max heap tree, to delete or insert an element will take best case 1, worst case average case log n, where n is number of elements in the min heap or max heap. I am reading once again, if anyone having small doubt also, I am reading once again. In min heap tree or max heap tree, to delete or insert an element will take best case 1, worst case average case log n, where n is number of elements in the tree, right? Fine, I am thinking you are absolutely fine now. So see this one, in the min heap tree insertion you know, deletion also you know, right? The next question is going to be, listen, the next question is going to be how to create max heap tree, right? In the min heap tree, max heap tree, insertion, deletion you know. If you know max heap means you know min heap also, right? Please be careful. Next one, how to create max heap. Let me explain that also, right? I am explaining. Deletion, insertion you know. Next one is how to create max heap. I am writing, see this one. How to create max heap, right? This is the topic name, how to create max heap. So how to do that I will explain. See this one, for how to create max heap, that is the story. For that this is the way. See the solution. How to create max heap, this is the solution. Using build heap you can do that. Using build heap you can create max heap. Using build heap we can create. How to create max heap tree? Answer is going to be using build heap we can create. Using build heap we can create. Can you help in how much time? I am writing the time also, within few minutes I will explain. How to create max heap tree? Answer, using build heap we can create. Some people are asking how much time. See, I am writing the time also. How much time? See this one, order of n time. And one more thing, every case, not best case, not worst case, every case. How to create max heap? Using build heap we can create it. How much time? Order of n time. Which case? Every case. Why? If you want I will write that also. Order of n time every case, where n is number of elements. So if you have n elements, to create max heap or min heap will take n time, where n is number of elements. I am repeating once again. To create max heap tree or min heap tree using build heap will take order of n time, where n is number of elements. N elements are there to create max heap n time, right? N elements are there to create min heap n time using build heap. Please be careful how to do build heap. I will explain, right? I am starting now. Our goal is build heap only. How to do that I will explain. See the answer. See the answer now. One example I am giving. Can you help me now? If you want to create min heap or max heap using build heap method, what is the input? Input should be one array. Array with n elements required. See the input. An array with n elements. Let me write now. 50, 75, 85, 30, 26, 41, 90, 23, 36, 88, 77, 66, next one 120, 130. There may be so many elements. Let me count here. 3, 9, 12, 15. 15 elements are there. If you want, I will add few more elements. Next one is going to be 68, 79, 49, 33, Next one is going to be 77, 86, some numbers. Don't worry. So I think 15 plus 3, 18, 18 plus 3, 21. 21 elements are there. How to create max heap tree using build heap, I will explain. I will do one example for your practice purpose. One more example also I will do. 2 examples I will do. Please take care. See this one. This is the input. Output, see the output. How to create, I am explaining. Output is going to be first step. Right? For these elements, if you want to create the max heap tree using build heap method, output is going to be this one. Right? All the elements, whatever is there, right in the form of a almost complete binary tree. Means how? 50, 75, 85, 30, 26, 41, 90, 23, 36, 88, 77, 66, 120, 130, 68, 79, 49, 33, 77, 86. Right? These are first step. If you want to do build heap to create max heap tree, first step is going to be create almost complete binary tree. Almost complete binary means what? Just write level by level, nothing there. Without gap you write. Right? So first create almost complete binary tree. Yes, I created. After creating, right? Give the indexes also. Index numbers also give. I am giving index numbers. 1, 2. Why index number? Inside computer no tree, nothing. Everything is array only. Inside array format only. Inside like this only. Inside the computer how the tree? Like this. For our convenience I drawn the tree. Both will be similar. There is no extra work here. Some people are asking, sir, you created the tree, how much time? No, both will be similar. This is for computer, this is for us. Please be careful. If you do directly here, so many formulas you have to apply. If you do here, no formula, nothing, because it is directly visible. Both are same, I want to say that. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Right, 20 elements. Please check 20 elements how? Let me check here. So, if any element is missing, let me check here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. There are 14. Right? I think 14 plus 6, 20. Fine. It's okay. No problem. So, I took one array. To that array, I have to create the max heap tree. Yes. First create the almost complete binary tree. Yes, I done. Now see the next step. After creating almost complete binary tree, let me ask you one small line. Listen. After creating almost complete binary tree, let me ask you one small line. Can you help me now? What is the meaning of, you only say, what is the meaning of this one? What is the meaning of max heapify top? Max heapify top. What is the meaning? Max heapify top is nothing but what is the answer? Parent will ask both the children. See, parent will ask both the children. Max heapify top means parent will ask both the children, right? Whoever is better than the parent, with him swap. Suppose right child is better, with him swap. Right? I am repeating once again now. Max heapify top is nothing but parent will ask both the children, whoever is better, with that swap. What is the meaning of swapping? Parent will go down, child will go up, like this. Now because the parent is came here, wrong person is came here, maybe if at all children are there, you have to ask again, right? Everyone now. Max heapify top means what is the answer? I think in the case of deletion we used to do that. In the case of deletion we used to do this. What we used to do? Right? Parent will ask both the children, whoever is better, with that swap. That is the meaning of max heapify top, everyone know. Right? And one more thing I want to ask you. Listen, before going to start, one more thing I want to ask. What is the meaning of for loop in the reverse order? For loop in the reverse order, what is the meaning? For loop in the normal order is I is equal to 1 to n. For loop in the reverse order, what is the meaning? Right? For I is equal to n to 1. For loop reverse order means for I is equal to n to 1. For loop normal order 1 to n, right? Please be careful. Right? I am thinking that you are absolutely fine. I am repeating again. Maxify top means parent will ask children's. Right? Whoever is better with that SPAP. Suppose parent only better, don't SPAP. Don't SPAP means don't go further. But if you SPAP means you have to go further. If you have to go further if children's are there. If not there, you can stop. Maxify top means parent will ask the children's, please be careful. Right? See this one. I given the direction also. Parent asking child 1, child 2. See the direction also. Parent asking children, whoever better with that SPAP. Right? Next one. For loop in the reverse order means, normal order means 1 to n. Reverse order means n to 1. Please be careful. Everything ready? Now I am starting. See the maxify top. Listen everyone now. See the build heap method. I am starting. See the build heap method. Build heap method is nothing but, carefully listen, build heap method is nothing but for loop in the reverse order. Normal order means what? 1 to 20. Reverse order means 20 to 1. For loop in the reverse order means what is meaning? 20. 20 to 1. After 20, 19. After 19, 18. After 18, 17 and so on. Right? After 2, 1. For loop in the reverse order, that is the meaning. So, take the for loop in the reverse order, I value 20 now. So, for loop in the reverse order, it's okay. Means I value 20. That is also okay. Right? From this place, listen. From this place onwards. Right? Just to take the for loop in the reverse order, I value 20. Just to go to the 20 index, what will you do? To that index, 20th place, whoever is there. To this, apply maxify top. What is the meaning? Maxify top is nothing but, he will ask their children. See, maxify top means parent ask children. You want to ask their children, is there any child here? No. Means no work. Again, for loop in the reverse order, after 2019, here also maxify top apply. You want to ask their children, not there, no work. Children's not there, no work is there. You know, problems are there when children's are there. Whenever children's not there, where is the problem? Next one, 33, right? He will ask their children, not there, no problem. He will ask their children, not there, no problem. It says one, maxify top means parent will ask children, not there, no problem. After 16, next one, 15, right? Not children's not there, no problem. Children's not there, no problem, like that. So I think by seeing this one, now people got to know why I done, why, see this one, now people got to know after doing this much work, why I took these many elements. Why I took for half of the element, no work. Right? For half of the element, no work is there. Right? So for loop in the reverse order, see, some people are asking, sir, why I am doing this much work? This is the method. Build heap method is doing like this. Build heap method purpose is going to be creating maxi. That is okay. How to create? He will take for loop in the reverse order at everywhere he will apply, right, maxify top procedure. For loop in the reverse order he will take, at every node he will apply maxify top procedure. But half of the nodes are leaf nodes. Out of n by n people, n by 2 people are leaf, n by 2 is non-leaf. Right? Because of n by 2 people are leaf, means they don't have children. Children's not there, no work. Maxify top means what? Parent will ask child not there, so no work. That is the reason I am taking those many elements. I took so many elements because half of the people don't have any work. Can you help me now? From where actual work will start? From the first non-leaf, from bottom, there actual work will start. Right? First non-leaf, see this one. First leaf node, no work. From the bottom, first leaf node, no work. Second leaf node, no work. Actual work will start from first to non-leaf, from bottom. From bottom, first to non-leaf. I think this one. Right? I think 10th element. Onwards, right? Work is there. What is the work? Let's check. See, what is the work? At everywhere apply maxify top. What is the meaning? Parent will ask child. Right? Is there any problem? No. No work here also. Next one. Parent will ask child. Is there any problem? 33 saying no problem. 77 saying problem there because maxify means you should be bigger, I should be smaller. But reverse there, swap it. What is the meaning of maxify top? Parent will ask the children, right? You are going down, please be careful. Parent asking children, right? See this one. He is not asking somewhere else, right? Parent asking child. What is the meaning? He may go down. When you say maxify top, parent will ask child, any problem there, he will swap. Right? Now see this one. 36, 33, 77, better one, 77, 36. See this one. He came down. He want to go further if anyone there. Not there, stop. I think it is also over. Let's come here. If anyone having small confusion, same. Maxify top. What is the meaning? Parent will ask child. If anyone is better, he will swap. 23, 79, 79. 79, 49, 79. Better, 79. So, I think 79 here, 23 here. So, he came here, he went there. Right? So, see this one. Parent asking child, with the one of the child, he will swap. After swapping is over, he want to go further, but not there, stop. 8th also over. Let's go to the 7th. 90, 130, 68. Who is better? 130. 130 here, 90. After swapping, you want to go further, but no chance. Next one, go to the sixth element also. 41, 66, 120. 120 better. 120 here, 41 here. You want to go further, but no chance. Let's come here now. 26, 88, 77. Who is better? 88. 88 here, 26. See the interesting answer. 26 came to here, right? Right. Swapping is done. Again, he will ask their children. That is the meaning of max if I top. Right? He will ask their children. Problem there, swap. Swapping is done. Right? If at all further there, you have to ask. Can happen 26, 86. I think 86. 86 here, 26 here. So he came from here to here. Next one, this also over. Let's go to the fourth one. 50 is completed. Let's go to the fourth one. 30, 79, 77. What is the answer? 79 here. Right? 30 here. Again same. 30, 23, 49. What is the answer? 49 here. 30 here. So this also completed. Fourth. Let's go to the 3. Next one. See this one. 85, 120, 130. What is the answer? 130 is here. 85 here. Next one. 85, 90, 80, 90, 68. What is the answer? Right here. I think 90. Here 85. This one he came down here, right, like this. That is also okay. I think 3 over. Let's go to the 2. 75, 79, 88. What is the answer? 88 here, 75 here. Next one, 75. 86 is 77. What is the answer? 86. 86 here, 75 here. Next one, 75, 26, no problem. This also completed. Let's go to this one also. At every node apply max if I top. What is the meaning? Parent will ask child, problem there, swap. I think 2 also over. Let's go to the 1 now. 50, 88, 130. What is the answer? 130, 50. Because the swapping is done. Again he will ask their children's. What is the answer? 120, 90, 120, 50 here. Next one, 50, 66, 41. What is the better? 50, 66, 41. What is the answer now? 66 here, 50 here. Please check if I done anything wrong. There may be wrong, after all everyone is human. 130. Please check, is it max C parlan? Please check. 130, 88, 120. Right side, left side if you see 88, 79, 86. 79, 49, 77. 49, 23, 30. 77, 33, 36. 86, 75, 77. 75, 26. Fine. Go to the next one. 120, left 66, right 90. 66, left 50, 41. Next one, 90, left 85, right? Right is going to be 68. I'm thinking you are absolutely fine. I'm thinking you are absolutely fine. Right? Let me check one small line. Can you help me? What is the root? Same thing, whatever happened until now, I am writing. If you want, you can verify also. What is this one? 130, first level. Second level? Second level, 88, 120. Can you say third level? It is the third level. What is the third level? 79, 86, 66, 90. What is the fourth level? 49, 77, 75, 77, 50, 41, 85, 68. What is the fourth? What is the fifth level? 4 levels are over. What is the fifth level? 23, 30, 33, 36, 26. Right, like this. 130, 88, 120, 79, 86, 66, 90, 49, 77, 75, 77, 50, 41, 85, 68, 23, 30, 33, 36, 26. Right? So this is the max heap tree. This is the way how to construct max heap tree using build heap method. What is the time complexity? Order of n. How? I will explain within a few minutes. So can you help me if anyone asks you build heap method, what can you explain? What is the answer? Nothing. After taking array, create almost complete binary tree first. Next, for loop in the reverse order start. Next, each I value do max if I top. What is the meaning of max if? When you say max if I top, assume that max if I top, I am at a parent, I will go down only. Max if I top, what is the meaning? Parent will ask children whom you are asking, those only will change. You cannot change above. max if5 top, parent will ask children, means you will go below only. Below not there, stop, right? So max if5 top apply at every way where for loop in the reverse order, right? Just to do one scan from the bottom to top. But while doing that, every node apply max if5 top. If you want, I will write the single English line, right? What is the max if5 top? See this one. What is the build heap method procedure? See this one. Build heap. Listen once now. Only for namesake I am saying. Build heap on array A which contain. See this one, right? 1 to n. Build heap on array A which contain 1 to n is equal to, see the answer, is equal to, otherwise you can write n also. Array A which contain n elements is equal to, see this one, for I is equal to n, right? I greater than or equal to 1, right? I minus minus. Each I value, what I have to do? Max if5. Max if5, right? I. At every I, apply max if5 procedure. This is the procedure. I value n, apply max if5 n. What is the meaning of n? Position. At the nth place, apply max if5 procedure. N value how much here? N value how much here? 20. 20 apply max if5 procedure. Next one 19 apply max if5 procedure. Continue until 1 will come. This is the program. And one more. In this program, if you observe, there is a one for loop. Time complexity is going to be that for loop only. What is the answer? Order of n. Which case? Every case. Some people are asking, sir, each I value are applying max if5. Yesterday we done. Max if5 will take, right? Max if5 will take log n time worst case. How can you say overall is n only, right? Because of some decreasing GP series coming, overall value becomes n. Because of some decreasing GP series, overall becomes n, right? Please be careful. Just this is the build heap method. One for loop, each I value called the max if5 procedure. Max if5 procedure normally will take log n. Here also it will take log n, everything is okay, right? But overall, right? One decreasing GP series coming, right? Final answer becomes n only, right? N followed by one decreasing GP series, n into order of 1, finally order of n. So I am thinking that you are a little bit okay. To get the more clarity, let's take one more example. I am giving one more example. Please see this. If those people who are having small doubt also, please see this also, right? I will explain the time complexity also how it came, right? See this example. Some elements, let me take input one array. Input is one array, let me take it. See this one, everyone? See this one, input 70, 20, 55, 85, 26, 99, 120, 79, next one 36, 23, 49, 55, 29, 38, 89, next one is 17, 7, 6, some elements. I don't know how many elements, not required also. Can you help me now? First step. You want to create almost complete binary tree, first step. Let's create 70, 20, 55, 85, 26, 99, 120, 79, 36, 23, 49, 55, 29, 38, 89, 17, 7, 6. 70, 20, 55, 85, 26, 99, 120, 79, 36, 23, 49, 55, 29, 38, 89, 17, 7, 6. Right, like that. First create almost complete binary. After creating, let me give numbers also. I am giving numbers. Array index, these are array indexes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right, like that. Give the numbers also. Yes, I given numbers. What is the next one? Right. So for loop in the reverse order, apply max if5 top procedure. Reverse order. What is the meaning? Start from 18 onwards. For loop in the reverse order means from here onwards apply max if I top procedure. What is the meaning of max if I top? If you apply max if I top at this place, he will ask their children, with them you spare and you will go further if there, because of not there, right? Work is over. Next one, max if I top here also, below not there. Max if I top here also, below not there. So after 16, next one is 15. Here also not there. So half of the, right, half of the leaf, total nodes are n. In that half is leaf node. Leaf nodes don't have any work. Actual work will start from first non-leaf node. First non-leaf node, please be careful. First non-leaf node onwards, work will start. Right? Can you help me? How many people? Some people are asking. First non-leaf node means how will you calculate? Let me calculate. What is 18 by 2? 9. See this one, no fraction came, no fraction. So I think 1 to 9 is going to be right, non-leaf. From the 10 onwards, which is going to be leaf. Right? So 18 by 2, which is going to be 9, until 9, fraction not there, until 9 non-leaf. Right? After 9 leaf will be there. Suppose assume that one more element is there. Assume. I will remove also. Assume that one more element is there, 19. Can you help me now? 19 by 2, how much? 9 point something. Assume that 9 point something. Can you help me? Until which place non-leaf? Until which place non-leaf? Until which place 9.5. Right? Take the, if you take the ceiling value, it will become 10. Means you are entering into the, you know very well, ceiling value is going to be leaf. Ceiling value is going to be leaf, right? I think floor value is going to be non-leaf. Just what will you do? Just take the ceiling value, right? Just take the ceiling value. What is the answer? It will come 10. If you take the floor value, how much will come? 9. So from here onwards, the actual work will start. Here onwards. Can you help me now? Off is leaf, off is non-leaf. If anyone having small confusion also, until now whatever I said, small confusion also, please see here. So assume that 18 elements are there, 18 by 2, 9. So 9 is going to be, what is the answer? Last non-leaf node. From the bottom, first non-leaf node. From the bottom, first non-leaf node is going to be 9. If at all, see this one, if at all no fraction, 9 only. If fraction will come, take the floor value or ceiling value, right? 19 by 2, 9.5, take the floor value. What is the answer? 9, right? 9 onwards, 9 is going to be first non-leaf node. Actual work will start from 9 only. First non-leaf node, from the bottom onwards it is working. From the top, it is the last non-leaf node. From the bottom, first non-leaf node. From here onwards, work is starting. I will change the algorithm little bit, please see. This is the algorithm. See everyone now, build the heap method. See the algorithm. For I is equal to n2, I greater than or equal to 1, I minus, max CP5, I. Can you help me now? So from the n onwards, the actual work is starting, or from the first non-leaf node from the bottom? First non-leaf node from the bottom. So what will you do? N by 2, right? Floor value you take. From here onwards, the actual work is starting. Not n also, n by 2. N by 2 onwards, floor, first non-leaf node is coming, from there onwards work is starting. So half of the people no work, see this one, these all people don't have any work, remove this, because it is not there in ours, right? Let me start this. So see everyone now, build the heap method I am doing on this particular array, let's check. So start here, see start here. So just I think because of leaf node, no work. If I want to do max CP5, see this one. If I want to do max CP5 top, right? So parent will ask child. They don't have child. That there is no work. I think here. Parent will ask child. No problem. Here. Parent will ask child. No problem. Right? After 8, next one is 7. Parent will ask child. Please check anywhere wrong. Parent will ask child. No problem. Parent will ask child. No problem. Parent will ask child, I think problem there where 49. So 49 here, 26 here. After swapping, go further, but no chance. Come to the next one now. Parent will ask child, right? What is the answer? No problem. Next one, parent will ask child, I think problem there. 120 here, 55 here. Again here, 55, 89, 38, 89. What is the answer? 89 here, 55 here. So this also completed. Let's go to the second. Right? So you will ask both the children. So what is the answer? I think it is 85, it is the 20. Next one, 75, 79, 36. What is the answer? 79 here, 20 here. Next one, you will ask both the children. So what is the answer? No problem. Leave it. 2 also over. Let's go to the 1. 70, 85, 120. 120, 70. Next one, 70, 99, 89. What is the answer? 99, 70. Next one, 70, 55, 29. So 70. Check properly, right? So this is the answer. Whatever you got until now, right? Let me write answer once. See this one, what is the first one? 120. See the second, I'm just writing outside, nothing there. 85, 99. Next, third level, 79, 49, 70, 89. Next, 20, 36, 23, 26, 55, 29, 38, 55. Next, 17, 7, 6. Right, so these one. Please check. Same thing I just written as it is. Now let's see the time complexity also. See the time complexity. I am calculating time complexity. What is the time complexity without calculation also? I said many times. What is the time complexity? Order of n. N nodes are there. Everywhere you are applying max CP5 top procedure. Normally max CP5 top will take log n. N elements are there. Actually n log n. But it became less than, right? Less than n log n. That is a n. The reason is decreasing GP series going on. I will do that also. See this one. I am doing that also. Carefully observe what is going on. I am doing that also. Make sure that everyone listen, right? So can you help me now? So is it complete binary tree or not? Few gaps there. Assume that those gaps also not there. Here few gaps are there. I want to find out time complexity. Assume that these gaps also not there. Assume. Maybe I want to give upper bound to you. Nothing there. Assume that these are also full. Now I am starting. See this. See everyone. I'm explaining building heap method time complexity order of n. How? I'm explaining. Two examples I given. Now I'm explaining the time complexity also. One time you listen. Please see correctly. See correctly here. Assume that in this tree, total nodes are n. Assume. In this tree, total nodes are n. Assume that. Can you help me now? In this tree, if at all total nodes are n, at this level, how many nodes are there? In this level, see this one. Total nodes are n. In this level, how many nodes are there? Everyone. What is the answer? N by 2 nodes. Half will be leaf, half will be non-leaf. Can you help me? In this level, how many? N by 2 by 2, n by 2 square. If you want, you can check. This one, n by 2 square by 2, n by 2 cube, and so on. Here, how many? Right? N by 2 power log n. 2 power log n base 2 is going to be n. N cancel 1. Right? Like that. Assume that total tree contain n nodes. Definitely half will be leaf. Right, 2 people becomes 1 person, right? One more half. If you divide by 2, everyone know, right? Mean heap tree contain log n levels, right? I think 2 power log n. N by 2 power log n base 2. 2 power log n base 2 becomes n. N cancel 1, right? It is the current status. Fine. If you are comfortable, see this one. If you are comfortable, see the one more interesting line. What is coming? Can you help me now? In this level, n nodes are there, it's okay. In this level, n by 2 nodes are there, it's okay. Please help me now. At everywhere you applied the max CP5 top procedure, that is okay. Max CP5 top means what? Parent will ask children's not there. Can you help me now? So whom they will ask? Their children's not there. So how many comparison? If 2 children's are there, right? See this one. 2 children's are there, 2 comparisons you will do. If one child is there, one comparison you will do, but one thing is true. 2 children are there, one child is there, it doesn't matter. But number of SPAPs are 1 only. 2 children, ask both the people who is better SPAP. Right? Next one, 2 children, right? Ask, right, who is better with that SPAP. Comparisons are 2, 1 SPAP, but one thing is true. See this one, I am finding SPAPs only. Why? If I find out the SPAP, comparisons are double. Why? 2 comparison, 1 SPAP. 2 comparisons, 1 SPAP. Compare both the children with the better one SPAP, right? Like that. If you find out SPAPs, you can find out comparisons also. SPAPs are 1, means comparisons are 2. SPAPs 2, comparisons are 4. Why? Right? 2 people compare, 1 SPAP. Again 2 people compare, 1 SPAP. Try to remember. For the SPAP, comparisons are doubles. Right? I am finding SPAP only because using SPAP I can find out comparisons also. Right? Now let me check this one. This person required how many SPAP? He want to ask their children and they want to SPAP with him, but unfortunately not there. So SPAPs here 0. Here swaps how many? E also want to ask their children, E want to swap, here 0. So these are all leaf nodes, n by 2 leaf nodes are there, everywhere 0 swap required because they don't have children, that is the reason. Let's come to next level, you may get clarity at this place. At this place max if I top procedure, what is the meaning? He will ask both the children, with one person he will swap. Swaps how many? 1. Everyone 1 swap. Comparisons are double. Afterwards I will calculate that also. Let me calculate swaps. At this place, right, he will ask both the children to comparison with the better one swap. He will ask both the children compare with the better one swap, right? I think maximum one swap, maximum. Sometimes no swap also, maximum one swap. So everywhere maximum, I am taking the maximum swap. Sometimes no swap also there. Next one, come here now. What is the answer? Here again max if I top procedure. What is the answer? Ask both the children swap. Ask both the children swap. So what is the answer? I think 2 compare 2 swaps at everywhere maximum. Again I think here also it will continue. See this one. It is the 2 power this one. It is the 2 power 1 0. It is the 2 square. It is the 1. It is the 2. It's this one. It is the 2 cube. It is the 2. Please check here properly. Can you help in what may be the next one? Can you give roughly here? Roughly here. What is the answer? N by 2 power 4 into how much? 3. Check properly. So it is the 2 power 1 means 0. 2 square means 1. 2 cube means 2. 2 power 4 means 3. That is okay. Can you help in what may be this one? Right? What is the answer? Log n minus 1. 1 less. 4 means 3. 3 means 2. 2 means 1. 1 means 0. Here log n means log n minus 1. Like that. Right? Can you say what is this one? Number of nodes at this level. Right? What is this one? What is this one? Number of swaps at every node. Total swaps these many. Total swaps these many. Total swaps these many. Like that. At that level total swaps how many? If you add all, total swaps will come. At this level total swaps how many? This will give. At one node swap this. How many nodes this? If you multiply, total swaps at this level will come. Total swaps at this level, you add all of them. Right? Total number of swaps will come. I will do that also. See this one. See, make sure that everyone listen. Total swaps is equal to. Total swaps is equal to. What is the answer? Just I think that formula. What is that one? N by 2 into 0 becomes 0. Leave it. Remaining. What is the answer? N by 2 square into 1. N by 2 cube into 2. N by 2 power log n into log n minus 1. Right? If you common, what is the answer? N by 2 if you common. What will happen? It will goes to 1 by 2 whole power 1 into 1. Next one 1 by 2 whole square into 2. Lastly 1 by 2 whole power log n minus 1 into log n minus 1. Right? Fine. I am thinking that until now it's fine. See the next one. N by 2 common. Can you help in what is this one? APGP series. APGP series. I think in every way, second term if you see AP term, if you see the first term GP term, it is the APGP series. Can you help in how to solve the APGP series? If you solve the APGP series, right, how to solve? In the GP series, find the R value, multiply, right? Afterwards subtract, all the AP terms will go, only GP terms will come. What are those? 1 by 2 whole power 1, 1 by 2 whole square, 1 by 2 whole power 3, lastly 1 by 2 whole power log n, right, which will goes to n by 2 into, I think it is the decreasing GP series. See this one, it is the GP series, R value less than 1. What is the answer? Constant. So finally, right, it is approximately n by 2. This is total swaps. Can you help you know? Comparisons how many? Total comparison. Total comparisons. Total comparison is equal to what is the answer? 2 times of swaps. Right, which will goes to 2 into swaps how many? N by 2. Finally, I think n. Total swaps are these many. Total comparisons are double for that. Right. Next one. See this one. Time complexity of. See everyone listen. Time complexity of. Right. Time complexity of build heap. Time complexity of build heap. Time complexity of build heap is equal to what is the answer? Comparisons plus swaps. Comparisons how many? N by 2. Sorry, comparisons are n. Swaps are n by 2. Overall 3n by 2, which will goes to big O of n. right? Which case? Every case. Why every case? For loop is there. Loop compulsory should run. I thought that right, maximum will be more will come. Minimum n required because all elements at least one time you have to scan. So to do the build heap method, minimum n, I thought that maximum will come more because of this decreasing GP series. This one, because of this decreasing GP series, right? It decreases a little bit. So some people are asking, how can you say comparisons are double, right? See this one, after every 2 comparison, 1 swap there. After every 2 comparison, 1 swap there. You only say swaps are 5, comparisons are 10. Why? After 2 comparison, 1 swap. After 2 comparison, 1 swap. Comparisons are n by 2. Sorry, swaps are n by 2. Comparisons are going to be double. So n. Next one, time complexity of build heap. Everyone in the build heap method, every time comparing swap only. So comparisons plus swaps if you do, right? I think total time will come. So can you help me now? Comparisons how many? N. Swaps how many? N by 2. Add them, order of n. This is the time complexity of build heap method. So build heap method purpose, 2 examples I said to you. It is the first example, see this. So can you help me now? Build heap method input, 1 array, output, right? Max heap tree. How will you do that? One for loop is going on, right? That for loop also reverse order, right? Every I value do, right? Max if I top procedure. But normally max if I top will take normally log n, right? So for 1 person log n by 2 people, n by 2 log n, which is nothing but n log n, I thought, because of decreasing GP series, n only coming. Please remember, many times I written, many times, proof really not required, many times I written, see this one, using build heap, we can create, right, max heap. How to create max heap? Using build heap, we can create max heap. How much time? Order of n time every case, where n is number of element. I given proof also how? I given proof also, see this is the proof. This is the proof for time complexity. Find the swaps first. Afterwards, comparisons find out. Add them. You will get the time complexity order of n. If you are comfortable with the proof, well and good. No one will ask the proof also. If you are comfortable with the proof, well and good. Otherwise also no problem. These 2 numerical examples are okay, right? Then you got the build heap method. 2 examples. Take the array and apply the max if procedure from the bottom. Once again take the array, apply max if procedure from the bottom, right? Please be careful. Now see 3 things I said again and again. What are those? Creating max heap, next one. Inserting a element into max heap, next. Deleting element from the max heap. Indirectly, directly in the exam, these only will come. Indirectly, directly in the exam, these only will come. Just be comfortable with insertion, be comfortable with the deletion, right? Be comfortable with the creating max heap. Can you help me? This entire story input array. After taking array, what will you do? Using build heap, create max heap. Next, after max heap tree is available, you want to delete something, delete. You want to insert something, insert. But one thing, every insertion deletion will take log n, average case and worst case. 1 best case. Right? Fine. So we completed the insertion, we completed the deletion, we completed the build heap method, 3 things over. Now it is the correct time to go to the right merge sort algorithm. Right? Before going to that, let me explain with the help of one example. Then afterwards I will write the algorithm. Afterwards I will say time complexity also. Right? Let me write this. See this one. One example. Heap sort, one example. Total heap sort, one example. Afterwards I will write the algorithm. See the example. Now. What is the input to the heap sort? 1 array, right? 1 array. Let me give some elements. 25, 38, 49, 26, 39, 88, 7, 23, 9, 31, 49, 3, and next one is going to be is in the date, some numbers. So this is the input. See this one, I am explaining heap sort algorithm. For that, right? To explain that particular algorithm, right? With the help of numerical example, I am explaining. Afterwards, I will go to the heap sort algorithm, right? See this one. This is the input. Right? Now see this one. What is the procedure? Right? To do the heap sort. See the first step. This is the input. First step is going to be, see this one. First step is going to be create max heap tree. Using build heap, using build heap. That is the first step. Create max heap tree using build heap. Right? So some people are asking, sir, what is the build heap? You know very well, right? Before that we done that only. Let me do the right build heap method. You know very well what is the answer? 25. Let me create the almost complete binary tree. 38, 49, 26, 39, 88, 7, 23, 9, 31, 49, 3, 8, right? It is the current status. So, season first step is going to, if you want to do heap sort, first step is going to be create max heap tree using build heap method. Yes. So, I took the almost complete binary tree. Next one. See the next one. See the next one now. Let me give indexes also. You know build heap method very well. Right. So, let me do the build heap method. Right? Can you help me? Build heap method actually will start from where? First non-leaf node from the bottom. See this one? From the bottom first non-leaf node. Means I think here. Right? You see, I think it is also leaf here. From here. Right? Build heap method will start from first non-leaf node. Right? I think here. From the bottom first non-leaf node. Some people are asking, sir, what is the formula? Can you say 13 by 2? What is the answer? 6 point something. 6 point something. Then what is the answer? You want the first non-leaf node. I think what is the answer? I think floor value you take. If you take ceiling value, leaves will come, right? So if you take the floor value, I think a non-leaf node, last non-leaf node from the top will come. From the bottom, first non-leaf node will come. Real work of the build heap method will start from, right? From the bottom, first non-leaf node. If you want directly using formula, 13 by 2 you do, fractions will come, take floor value, means from here, right? Actual procedure will start. So let me do the, build heap method very well. 2 examples I already done, right? Only to explain the heap sort, right? Just I am explaining with the help of one example. Let's start now. So apply the max heapify top procedure from the first non-leaf node from here. I am starting. So what is the answer? I think he will ask both the children's, right? E only better. These people no need to ask also because, right? Children's are there, I will ask. No child, right? That is no need to ask. Come here now. So he will ask both the children's. I think 49 is better. 39 will go here. He will go down only. Further not there, so he don't go. Next one. 5 over, let's go to the 4. 26, 23, 9. 26 better. After 4, go to the 3. 49, 88, 7. So what is the answer? 88 here, 49 here. Because the smaller one came down, there may be some problem in this area. 49, 3, 8, no problem. 3 over. Go to the next one. 2. 38, 26, 39. So what is the answer? 39 here, 38 here. Sorry for that. Right? 38, 26, 49. New number is 49. So what is the answer? 49 will go here. 38 will come. Next one, because of small, right? Some number is came here. So what is the answer? 38, 31, 39. I think 39 is better. 39 here, 38 here. So I think here also max heapify top procedure is over. Let's go to the 1. 25, 49, 88. Better one, 88. 25 here. Next one, 25, 49, 7. 49 here, 25 here. Next one, 25, 3, 8. I think 25 better. This is the case. Right? This is the case. I am thinking that most probably everyone is fine now. Let me write the output. Here. Same thing. 88. To see what is going on. Is it max heap tree or not? You can verify. Right? I think 88. Next one, 49. Next, I think this side also 49. 2 49s are there. What we can do? 49. Next one. This side. This side 26. No change. This one. Last number 39. Please verify properly. This one. 25. Right? This side 7. Right? This side 23. This side 9. 31. This side 38. This side 25. This side is 3. This one 8. So like this. On this tree, right? If you apply the build heap method, this is the answer what you got. Some people are asking, this tree becomes like this. How much time? What is the answer? Order of n. right? See this one, all the white color numbers only you see, that is the initial one, that is the array. This array means which one? This one. This array and this array both white color numbers only you see, right? So this array I converted into, right, using build heap method like this. It is a max heap tree. If you want you can check, it is a max heap tree. And one more, how the result will store in the form of array only. Result will store in the form of array only, input also in the form of array only, right? Max heap tree, min heap tree will store inside the computer in the form of array only, right? Let me see this one. How many numbers? 7, 8, 9, 10, 11, 12, 13, 13 numbers. Right, see this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right, 13 numbers, right? It is the current status. I am thinking that everything is fine, so let me remove unnecessary things. Right, so let me add all the numbers, let me keep all the numbers one by one. What is the answer? 88, 49, 49, 26, 39, 25, 7, 23, 9, 31, 38, 3, 8. So I think what is the first step? If you want to convert the, see this one, if you for the given, see this one, given array, if you want to sort using heap sort, first step, create max heap tree using build heap method. Yes, I done. How much time? Order of n. Because build heap method time complexity, order of n. So output is stored in the form of array only, everyone know, right? This is equal to this one, everyone know. Next one, this is equal to this one. On this array, I done the build heap method, I got this answer, time complex order of n, everything is fine. Now see the next story, see the second step. See the second step now. After completion of, after creating the max heap tree, right? See the second step. Everyone listen, delete, right? So from the max heap tree, delete. Afterwards, I will write what should I do. Let me do that also. See the answer. Delete. From the max heap tree, I am deleting. Can you help me now? Max heap tree root contain maximum element. Carefully listen. Max heap tree root contain maximum element. If I delete, maximum element will come. You know deletion also. See the interesting answer. And one more thing. This array contain how many elements? 13 elements. Please be careful. This array contain 13 elements. Right? Now let's see this one. Array contain, if you want, I will write. Array size n is equal to 13. Array contain 13 elements. It is the max heap tree array, right? Please be careful. It is the max heap tree array size is 13, everything fine. I am deleting now. See the answer. Whether I will delete here, whether I will delete here, both are same. You do whichever you want. Normally people are comfortable here, I am doing here. See this one, let me delete. Deletion, what is the first step? Store this one in one local variable. Yes, I stored. After deleting the root element, replace by last one. Yes, I done. After replacing by last one, right? The person whoever is came new here. So I think 8. This 8 and this area no relation at all. See this area and this 8 no relation because this 8 is came from somewhere. So he may be wrong also. That is the reason, right? Whoever having doubt, he will ask their children's. This is called as, right, max if top procedure. See this one, he is asking the left child, right? 8 and 49, who is better? 49. 49 and 49, who is better? Because both are same, previous one only. First two, 8, 49, 49, 49, 49, no change. So finally 49 is better. See this one, this 49 here, 8 here. I compared both, better one is, right, this 49 because both are 49s only. First 49 you have to take because next one is not bigger, that is the reason is not taken. In the similar way, because of swap done, further also check. Can you help me now? 8, 26, 39, who is better? 39. So 39 here, 8 here. Again, after swap over, right, parent will ask their children, 8, 31, 38, what is the answer? 38, here 8. So I think you deleted the root element, replaced by the last one, right? Afterwards adjust, that is called as max if I top procedure, everything is fine now. And one more thing, whatever you done in the tree, see this one, whatever you done in the tree, same thing is happening array also. Let me do array also. Let me do array. See everyone now, see everyone, same thing I am doing in the form of array also. See the first step. X is equal to 88. Yes, I stored. Next one, replace by last element. Replace by last element. Who came here? 8 came. Next one, replace by last element. He came here. That is fine. That means array, right? This element is no more because of he came there. Now, can you help? Now, previously array contained 13 elements. Now, array contain only 12 elements. Right? Array size 13, no doubt. Previously array size 13. Now also array size 13. But previously array contained 13 elements. Now array contain only 12 elements. Because of this element is when there, right, here one gap is there. Previously array size 13, elements also 13. Now array size 13 but elements are only 12 because of one element deleted, right? First element deleted, replaced by last one. I think it is the gap. This place gap is there, please be careful. Now next one, because of he came here, you have to adjust now. Can you help in how to adjust? Parent will ask children how to find out child, 2 into I. So I think to him left child is this one, right child is this one. Compare 8, 49, 49, 49, 49, 49. So finally 49 here, 8 here. After swapping is over, right? Again with whom you swapped, he will ask their 2 children. Who are those? 4 and 5. Can you help in 8, 26, 39, 39. Here 8. Right, with whom you swapped, he will ask their 2 children. Can you help me one smaller now? 2 into 5, 10. Right child, 11. Compare 31, 38, 8. Who is the better? 38. So 8 here. Now who is the left child of 11? 11 into 2 is 22. Not there. Stop. Means he is a leaf node. He is a leaf node. See this one. Multiply by 2, multiply by 2, multiply by 2 like that. That is. Can you help me one interesting answer? Right? See this one. From the max heap tree, you deleted first time. From the max heap tree you deleted first time. Can you help me now? If you delete, what happened? Right? This array contained previously size 13, elements also 13. Now array size is 13 but elements are only 12. Where is the gap? Last place. But one more interesting answer. If you delete from the max heap tree first time, what came? First maximum. From the max heap tree if you delete first time, first maximum came. See the interesting answer. From the max heap tree if you delete first time, first maximum came, right? First maximum came. And one more, first maximum came where I have to store this person, because of here gap is there. So one idea is delete the first time, first maximum came, store in another array. One more idea, in this array already gap is there. Why can't I will store here? Let me store until here only. Now array contains 13 elements, array size is 13, elements are only 12. Means one gap is there. In that gap you can store 88. I am repeating once again. This array size is going to be 13 but number of elements are only 12. Means last place gap is there. As soon as you delete, first maximum came, store in last place. Some people are asking, sir, how can you store? This is not part of the, see this one. This is the part of output. This is the input. From here to here only max heap tree contain elements. Here to here max heap tree contain element. This is the part of the result. Please be careful. Some people are asking, sir, why don't you store in another array? If I store in another array, space will be more. Anyhow space is waste here. Why can't I will store? So this is the max heap. This is the max heap. Now once again let me ask you. Once again. Can you help me? Let me delete one more time. What will happen? If you delete one more time, what happened? See this one. X is equal to 88 is over. Next time. Next time. After 88, next one. Isn't that one more time I am deleting? 49 came. One more time I am deleting, 49 came, right? Fine. 49 came, it's okay. Next one, replace this one by last one. See, this is the part of the input, right? Delete the root, replace by the last one. Yes, I replaced. Replace by the last one, I replaced. Next one, because of he came to this place, right? Here gap is there, here gap. Now, adjust now. How to adjust? Let me remove all these. Right, how to adjust? Let us see, here 3 came. How to adjust? I am explaining now. See, I am explaining. See this one, 3. I think he will ask left child, right child. Can you help me now? 39, 49, better, 49. 49 here, 3 here. Next one, he will ask their left child, right child. 3 left child, 6, right child, 7. So what is the answer? 25, 7. 25, 7 and 3. Who is better? 25. Here 25, here 3. Next one, I think 6 left, 2 into 6, 12. 2 into 6, 12. I think you see this one here, no more element. Because one element is there, that deleted also. I think he is the leaf node, no need to compare further. Can you help me now? Second time deleted, who came out? 49. Who came out? 49. Right? See, you want to compare further, but no element. Because this is the part of the output. Input is there until 11 only. See this one. One element deleted. Input is there until here only. I think this is the gap. Because you want to compare, but no one is there. Because this element is already shifted there. Then what should I do now? Second deletion is over. Second maximum came. First time delete, first maximum. Second time delete, second maximum. Who is that? 49. But where that should be go? Because of one more gap came. 49 you can keep here. So every time what I want to say, every time delete, one maximum will come. That will be stored in the last place. Next one, can you help me? If I delete, who is the next one? First 88. Next one is 49. Next, if I delete again 49. This 49 also. Right? When you delete this one more gap will come. There, 49 will go. Like that, keep on going. Can you say next maximum? After 49, next maximum. See all of them once. With the next maximum, I think 39 maybe. Next 39 will come. Next 38 come. Like that all are going on. Now can you help me now? Can you help me now? What is the second step? Delete. See this one, delete 1 by 1 element. Delete 1 by 1 element from max heap. From max heap. See this one, delete 1 by 1 element from max heap and store from right hand side. Right? Delete 1 by 1 element from max heap and store from right hand side. Means from here onwards you have to store. Can you help me now? Max heap first time delete, first maximum, store from right. Max heap second time delete, second maximum, store from right, next right, next right, next right. If you keep on doing like this one, can you say 39 over, 38 over, next one, who is the next? See in the available one, who is the next one? Next better. I think if you observe clearly, so what is the answer? 39 over 38. I think in the available people maybe 26, I think so, 26, assume that 26. Next, 25, next, like that all. Can you help me now? First maximum, second maximum, third maximum, fourth maximum and so on. What is the first one, right? I think what is the answer? Last maximum means minimum. I think you will get ascending order. Delete 1 by 1 element, right? Delete 1 by 1 element from the max heap and store from right hand side. Right? Can you help? Continue n times. Continue n times because I want all maximum. Continue n times. Delete 1 by 1 element, right, from the max heap and store from right hand side. Continue n times. Right? If you continue n times, what came? I think right, maximum and so on, minimum. I think ascending order is k. Right? This is the story. This is the story. Now can you help me one small line now? Those people who are thinking that, sir, I want time complexity and all. If anyone thinking like that, I will give the answer. Time complexity very simple. Can you say what is the first step? Create max heap tree using build heap. How much time? Build heap method always n time. Every case. Right? What is the next one now? See this one. Delete 1 by 1 element from max heap and store from right hand side. Can you help me now? One deletion will take how much time? One deletion will take how much time? Log n. One deletion log n. Continue n time. Right? N into log n. So what is the answer? N log n. So one deletion is log n, worst case and average case. Right? So if you do n time, n log n. Let me write now. Second step will take, what is the answer? Big O of n log n. Big O of n log n. And one more thing, this is the every case. Some people are asking, sir, how every case? Let me check this one. See this one. Deletion order of 1 is possible best case. Deletion order of 1 is possible best case. That is fine. Right? That is fine. But one thing, because of your in the max heap tree, if you delete root, replace by max heap tree, if you delete root, replace by the last one. Replace by last one. Can you see in the max heap tree mostly who are the last people? Smaller people. If you replace the larger one by smaller people, mostly it will come down. Mostly it will come. 99% it will come down. 1 or 2 times maybe it will stay. So see this one. Every deletion is every n deletions you are doing. 1 or 2 deletions may be constant. I am okay with that. Right? But you are doing n deletions you are doing. Mostly all are going to be how much? Log n. If anyone asks you one deletion time best case, order of 1 you say, n deletions I am doing in the max heap tree, right? What will be the time complexity? Every deletion log n, like that n time n log n. They may ask you, deletion best case is 1. 1 or 2 deletions best case 1 possible. Not all. Please be careful. Mostly log n will come. 1 or 2 occasions maybe 1 will come. What is the reason? The reason is going to be max heap tree, topmost one is maximum element. You are replacing maximum by last level people which are smaller. If you keep the top place where maximums are there by smaller people, mostly they will come down. That is the reason, right? Deletion time complexity, best case, right? Best case is 1, worst case average case log n. If you do one deletion, if you do more, right, most of deletions becomes log n. That is the reason every case is n log n. Now can you help me? Creating min heap n, deletion n time n log n, finally n plus n log n, finally what is the answer? N log n time complexity. This is the heap sort story, right? N log n time complexity every case. Please be careful, right? Every case. Delete 1 by 1 element from max heap and store from right hand side. Continue n time. Time complexity becomes n log n every case. And one more thing I want to ask you. So this is the algorithm. First create max heap tree, afterward delete n time, so time complexity becomes n log n. That I am okay with that. See this one. See everyone. See everyone. So I think note or whatever it is. Note. Right? Note or whatever it is. I am saying the first point. See the first point. See the first point everyone. Can you help me now? Can you help me one small line now? So which tree you created? Max heap. Which tree you created? Max heap. That's okay. Right? Max heap, if you keep on deleting, what you will get? Maximum, maximum, maximum. Are you storing the result? Right? Every deletion, one element is coming. Are you storing the result in another array or same array? Same array. Result also you are keeping in the same array. You are not taking another array. What is the meaning? Heap sort is a in-place sorting. Within the array you are trying in-place sorting. If you take another array and if you store, it will become out-place. It is in-place sorting. Please be careful. It is in-place sorting. See the second step. See the second step, one more interesting answer. Please listen. It is a max heap tree. If you keep on delete, right? If you delete first time, first maximum. Second time, second maximum. Third time, third maximum. You are storing the maximum from the left, from the right. From the right. Why? Gaps are on the right only. Every time gap is coming from right side. First time delete, right? Larger came, but gap is there at the last place, store. Next time delete, right? Next larger, next last is gap is there. You are storing from right hand side. Finally, who will come to first place? Who will come to first place? Minimum element. I think try to remember using max heap tree. Using max heap tree, if you do the sorting and all, you will get ascending order. Some people are asking max heap tree, if I delete first time, first maximum. I am getting starting first maximum, next maximum. Actually, I should get the descending order. How I am getting ascending order? You are storing from right hand side. If you store from right hand side, first maximum will go to last two, next maximum, next large, next maximum, next large, and so on, right? Last maximum, first two, means ascending order. Try to remember, max heap tree will give ascending order. Max heap tree will give ascending order. Please be careful. Let me write now. Max heap will give ascending order. Max heap tree will give ascending order. In-place sorting and max heap tree will give ascending order. Can you say what about min heap? Descending order. Min heap is descending order. Min heap will give descending order. And one more thing, listen everyone now. Listen everyone, max heap, min heap, which will give ascending order? Max heap will give ascending order, min heap will give descending order. Max and min heap, which will give ascending order? Max heap tree will give ascending order. Try to remember. Heap tree means, careful listen, because of max heap tree is giving ascending order, everyone now. Sorting means normally ascending, descending both will come. But most of the people will think that sorting means it's ascending order. Who will give ascending order? Max heap. Please be careful. Heap tree means, right? If anyone say from now onwards heap tree means max heap tree. Because he will give ascending order. Max heap tree. I am repeating once again, sorting means what normally people will think, ascending, descending both. But most of the people will think sorting means ascending order. Right? Who will give ascending order? Min heap or max heap? Max heap. Try to remember from now onwards. Right? If anyone say max heap, go for max heap. If anyone say min heap, then go to min heap. If anyone say heap tree means max heap tree. Please be careful because he is giving ascending order. Heap tree means actually min heap, max heap both will come. But which tree will give ascending order? Max heap. So heap tree means max heap. If you say in the exam max heap, go max heap. If you say in the exam min heap, then go to min heap. If you say heap tree, max heap, because he will give ascending order. It is in-place sorting algorithm. Max heap will give ascending, min heap will give descending. So heap tree means max heap tree. Time complexity is going to be n log n. Which case? Every case. Why? Deletion normally will take log n. Like that n time n log n. N time n log n. And one more I am writing here. Distinct elements. Try to remember elements all are distinct. Distinct elements. See, if other distinct elements are there, mostly deletion will take log n time. Like that n time n log n. Suppose all elements are equal, assume every deletion is 1. Like that n time, then n will come. If elements are elements are E said that most of the elements are same, then every deletion is 1. Like that n time, n will come here. Because most of the elements are distinct normally, right? So distinct element deletion will take mostly log n. Like that n time n log n. So time complexity of the heap sort n log n. What is the condition? Most of the elements are distinct. Suppose most of the elements are same elements are there, then what is the creating max heap is order of n. Creating max heap is order of n. Next one, deletion every time is constant, like that n time n plus n. If all elements are same, time complexity is going to be n. If most of the elements are distinct, time complexity n log in every case. That is a special case. All elements are same, that is a special case. Normally, when you say sorting, elements are normally distinct elements. So this is the heap sort. Right? This is the heap sort. Can you say heap sort first step? Let me minimize and let me explain. See this one. Heap sort algorithm I want to explain. First to create max heap. This is the creating max heap. After creating max heap is over, delete one by one and store. Store from right hand side because gap is there right side. So every deletion is log n, like that n time n log n. Next one, every case is n log n. What is the reason? If elements are distinct, mostly every deletion will take log n, like that n time n log n. Every case. Suppose if mention all elements are same, then every deletion is constant, like that n time n plus n will come. Right? Fine, that's okay. Normally sorting means distinct elements. It is an in-place algorithm. Max will give ascending, min will give descending. Now from now onwards, if anyone say heap tree means max heap tree. What is the reason? Max heap tree will give ascending order. I am thinking you are really comfortable. Let's see, one more small point is there. I will say that point also. Afterwards, see, there is a third point. I will write that also within few minutes. Let me explain first. Let me explain. Third point I will explain now. See this. See, listen everyone now. Listen. Ten. So see this one. There is a max heap. Actually, this is the array. See this one. This is the array. 10, like that 7 tens are there. 10A, 10B, 10C, 10D, 10E, 10F, 10G. There is one array which contains 10 sevens. See this one. 10, 10, 10, 7 times there. There is one array, right? 7 times 10 is there. To that I want to create max heap tree. For this array, I want to create max heap tree. So what I done? I kept in the almost complete binary tree. Yes, I kept almost complete binary tree. Then I want to apply build heap. Can you apply build heap from where? I want to create a max heap tree. Can you apply the build heap method? How? I think first non-leaf onwards. Who is the first non-leaf? I think if you go from the bottom, first non-leaf, I think this one. 1, 2, if you want I will write indexes also. 1, 2, 3, 4, 5, 6, 7. Right, from the first non-leaf. After 4, 3, I think here onwards. Here onwards I have to apply max if I top procedure. Let me ask, I will, parent is asking children. Let's check here, 10C, 10F. Right, both are 10 only, no change. Both are 10 only, no change. Next one, both are 10 only, no change. This one, both are 10 only, no change. I applied the right build heap method. So no change there because of all are same. Then what is the meaning of 10A? 10A means first two. In all the 10s, E came first. In all the 10, E came second, E came third and so on. 10G came late. Please be careful. Among all, E came late. Right? E came first. Right? After 10A, 10B came, 10C came, 10D came and so on. 10G. So I applied the build heap method, right, to create the max heap tree. Yes, I created. Let me write the result. I created, let me write the result. Nothing changed there. Same. 10A, 10B, 10C, 10D, 10E, 10F, 10G. 1, 2, 3, 4, 5, 6, 7. What is the array name? A. Right? So, see this one. This max heap tree I stored in the form of array. Yes, that's fine. Now let me do the deletion. You know sorting, heap sorting, right? Heap sort, you know, right? I am doing that. See this one? I am starting. Can you say delete root? Yes, I deleted 10A. 10A, delete root. Replace by last one, 10GK. Right? Because of you deleted this person, there is a gap. Right? So you delete the first one, replace by the last one. That's okay. Now 10A is out. Right? Next one. Next one. See the next one now. Right? So after last person is came here, you have to adjust also. Adjust now. He will ask left child. No problem. It's the 10G. It's the 10B. No problem. Right? He will ask 10C also. No problem. Finally, nothing changed. Same thing. Same thing. If you want, I will do here also. Delete 10A. Replace by 10G. replace by 10G and delete. See this one, same. Right? Previously until 7 elements are there, now until 6 elements are there. This is the gap. I try to next one, let's try to adjust using maxify top procedure, 10G, 10B, no problem, 10G, 10C, no problem, right? I try to adjust also, nothing changed. Next one, which when you delete first time, first maximum came, that will store in the last place. Yes, I stored, right? I think it went here. Same thing will continue further. But see the interesting answer. One deletion I done. Who came to the last place? 10A. I done one deletion, right? 10A came to the last place. But see the interesting answer. In the input, 10A is first place. But in the output, 10A went to the last place. That is the reason. Heap sort is not stable. It is not stable. Heap sort is not stable because of this reason. Right? What is the meaning of stable concept? Repeated elements order cannot change. Repeated elements order cannot change. But repeated order elements is changing. See this one. Before sorting, 10A is first to 10. In all the 10, first to 10 is 10A, right? But after sorting is over, right? First to 10 went to the last place. I think repeated elements order is changing. So it is not stable. That is the third point what I want to say to you. Let me write here. Third point. Heap sort is not stable. Heap sort not stable. So these are the 3 points. What is the first point? In place sorting it is. Max will give ascending, min will give descending. Right? So heap tree means max heap tree because he will give ascending order. Next one, heap sort is not stable because repeated element order may change. And one more thing, time complexity of heap sort is n log in every case distinct elements. Next one more thing, see this one, time complexity of heap sort is n log n, right? Every case distinct element. One more thing also I am writing, time complexity of heap sort is going to be order of n, right? Every case, right? If elements are same, elements are there, are elements same. Order of n every case, right? All elements are same. Distinct elements are there, n log in every case. See this one. When you don't mention anything, right? This only. If you mention special case, all elements same. Heap sort time complex order of n every case. When you don't mention anything, so generalized also you take this, right? So nothing mentioned, this is, right? If at a special case this is mentioned, this is the answer, right? I am thinking you are absolutely fine. This is the heap sort story.